As we continue our discussion on circles, we're going to keep looking at angle measures, and we're also going to bring some segment lengths in today. And we're going to look today starting with secant lines. Now you may recall we have talked previously about tangent lines. That was the first section of this unit. Tangent lines are those that intersect a circle at exactly one point. A secant line, on the other hand, intersects a circle at 2 points. Okay? Sometimes when you have more than one secant line, if you have two secant lines, they're going to intersect and they're going to form some angles. And so we've got some theorems that talk about the angles that are formed by that. If you have an angle that's formed inside a circle, so in this case angle 1 is inside the circle, then the measure of that circle, or the measure of that angle, is half of the sum of the intercepted arcs. So we add the two arcs together, divide it by 2. If, on the other hand, the angle is outside the circle, then that angle is half of the difference. So if it's inside the circle, we add. If it's outside the circle, we subtract. It's going to be very important to remember that because that can be easily confused. So if we look at these examples, here we have an angle x here that is formed by the intersection of two secant lines. It is inside the circle, so we're going to add. So the angle is 1/2 of the sum of the two intercepted arcs. All right, so x equals 1/2 of 46 plus 90. 46 plus 90 is 136, and half of 136 is 68. So angle x, the value is 68. Now in this example, the angle is outside the circle. So the angle is 1/2 of the difference of the bigger arc minus the smaller arc. Now because I've got an odd number here at 95, I really don't want to have to distribute my 1/2, so I'm going to multiply both sides by 2. When I do that, 2 times 1/2 cancels itself out, so I'm just left with 95 minus z. 2 times 20, I get 40. Now subtract 95 from each side. I have negative z equals negative 55. Multiply both sides by negative 1, z equals 55. So the measure of this arc is 55 degrees. Now let's continue with a couple of others. Here I have an angle outside, so that angle measure is 1/2 the difference of my two arcs, so w minus 110. Again, multiply both sides by 2. It makes it a little bit easier, so 140 equals w minus 110. Add 110 to both sides. 250 equals w. In this example, our angle again is outside the circle, so we're going to subtract. So the angle is 1/2 the difference of the two arcs. So y is 1/2. It's 110 minus 30, we get 80. So y equals 40. In this last one, the angle is inside the circle, so the angle is 1/2 of the sum. So we're going to add x plus 30. Again, multiply both sides by 2, so 70 equals x plus 30. Subtract 30 from both sides. 40 equals x. Okay. Not difficult, we just have to remember. Outside the circle means we subtract. Inside the circle means we add. Now if we look at this example, a satellite in geostationary orbit above Earth's equator has a viewing angle of the Earth formed by the two tangents to the equator. So satellite to A, satellite to B, we've got two tangents. So they intersect at just that one point. The viewing angle is about 17.5 degrees. So we have 17.5 degrees there. What is the measure of the arc of Earth that is viewed from the satellite? So we're looking at the measure of this arc here. I'm going to call it x. Well, the rest of it, the other part, is the rest of the circle, which would be the whole circle minus the x, what's left. Again, this is outside the circle, so that angle is 1/2 of the difference, so the bigger one minus the smaller one. So 360 minus x minus the smaller one of x. So I'm going to simplify inside my parentheses first before I do anything else. So I get 360 minus x, we have minus 2x. Everything in here is even, so I'm actually going to distribute my 1/2. So 17.5 equals 1/2 times 360 is 180. 1/2 times a negative 2x is negative x. If we subtract 180 from each side, we get negative 162.5 equals negative x. Multiply both sides by negative 1, we get 162.5 equals x. So the measure of the arc of Earth viewed from the satellite is 162.5 degrees. If we look at another example, this time the angle is 20 degrees. We still want to know the measure of the part that is visible to the probe. So this part is going to be x. This part is going to be 360 minus x, just like we had before. Again, it's outside, so it's 1/2 of the difference. So 360 minus x minus x. So 20 is 1/2 of 360 minus 2x. Again, distribute our 1/2 because everything is even. So we get 180 minus x. Subtract 180 from both sides. Negative 160 is negative x. Multiply both sides by negative 1. So 160 equals x. So we can see 160 degrees on this with this angle measure of 20. Okay. Now when we look at segment lengths, inside and outside is going to make a difference here as well. If we have two segments that intersect inside the circle, then A times B is going to be C times D. So if we think of part segment times part segment, we multiply the two parts together, set those equal. If it's outside, on the other hand, then we multiply outside part times the whole segment and set it equal to outside part times the whole segment. So if it's inside, it's part times part equals part times part. If it's outside, outside part times the whole equals outside part times the whole. Now if we look at this third example, we have T, which is a tangent. Well, the outside part is the whole, so it would be outside part, which is T, times the whole part, which is T, so you get T squared. Let's look at some examples. All right, here we've got segments, and they go inside and outside. So we're going to do outside part times the whole equals outside part times the whole. So 6 times the whole, which is 6 plus 8, equals 7 times the whole, which is 7 plus y. And now we simply solve our equation. So we have 6 times 14 equals 7 times 7 plus y. 6 times 14 is 84. If we distribute here, we have 49 plus 7y. Subtract 49 from both sides, and we get 7y equals 35. Divide both sides by 7, y equals 5. Over here, we're going outside the circle, so we're going to do outside times whole plus outside times whole. So z is the only outside times the whole, and that equals the outside part of 8 times the whole thing of 8 plus 16. So we have z squared equals 8 times 8 plus 16, which is 24. So z squared equals 192. That is not a perfect square, so we're going to estimate. Take the square root of that, we get approximately 13.9. Okay. Let's look at a couple other examples. Here again, we're still got parts inside and outside. So we're going to do the outside part times the whole thing is going to be equivalent to the outside part times the whole thing. So we have 14 times 34 is equal to 16x plus 256. We go ahead and distribute. So we have 476 equals 16x plus 256. Subtract 256 from each side. We have 220 equals 16x. Divide both sides by 16. And we want to round to the nearest tenth. If I actually carry this out, I get 13.75. But rounded to the nearest tenth, we have 13.8. Now here it's all inside, so we're going to do part times part equals part times part. So 6.5 times m equals 3 times 7. So 6.5 m equals 21. Divide both sides by 6.5, and I get 3.23, and it continues on, but we're rounding to the nearest tenth, so m is 3.2. Okay. So again, if it's outside, it's outside part times the whole, and if it's inside, it's part times part and part times part. Okay.